Hi, so this is page 522, number 27, and this provides us with a problem that is challenging not only in the sense that you have an improper integral, but it's our first time seeing an inverse trig function that might not necessarily be just the traditional parent function that you're thinking of. So we're going to start off by, remember there's two parts to this. First is you're going to set up the improper integral as a limit. So properly setting it up would involve that we replace both negative infinity and infinity. And in fact, because both of these are issues, we have to create this as two separate integrals. And I kind of think of it as like, you know, in my mind, if this was symmetric, that 0 is somewhere halfway in between. But really, it doesn't matter what value you pick for that middle, but 0 seems to be nice. So what we'll do is pick 0 as our split. Limit as b approaches infinity is the part that makes it improper. So we're going to go from 0 to infinity, 4 over 16 plus x squared. So properly setting up this improper integral. And then the other split of the integral occurs at 0, and that's going from negative infinity to 0, where the negative infinity part is what causes this to be improper. So we're going to go from b to 0. And that takes care of me setting up the improper integral properly with the limit. Now, off on the side, I'm going to do some work to find the antiderivative. So if you notice on this problem, I spelled antiderivative incorrect here, but you'll notice on this problem that you have a x squared in it and perfect squares with 16 and 4. And I'll show you this method, and it's really use substitution in your head for this type of integral, and we will see it frequently from here on out, so it'll become more familiar to you. And typically this is, if I ask you guys to pick an inverse trig function that this is really close to being the derivative of, you might say, well, it's really close to 1 over 1 plus x squared, where these terms here are 1. So let me challenge you to think about this in that way. So if I were to try to force this to be an expression with 1. One way to do that is to divide through by 16, but I can't simply just divide this by 16. I'd have to divide this term by 16 as well as the top. Or in other words, that would mean I would have to multiply the top by 1/16 and the bottom by 1/16 and make sure to distribute that. So overall, I haven't really changed the fraction in any way, but doing that adjustment, I get 1/4 on top. I get 1 plus x squared over 16. And I'm kind of taking a couple steps with this so that it makes the algebra of it a little bit easier for you. 1/4, and then the x squared over 16 could also be, verify it with me, that x over 4 quantity squared is the same thing as x squared over 16. So here we have an expression now with 1. And then the input of this function is x over 4. So let's check our work. If I guessed that this was arctangent of x over 4, and I were checking my work and making sure that its derivative is indeed the same thing as what I began with, I might take the derivative of arctangent and think of it as, so this is me just checking, maybe I'll check off on the side so it leaves room here. So this is me checking my work. The derivative of arctangent of x over 4 would mean that I would put 1 x over 4 in as the input for where x is for the derivative of arctangent. So this is the input. The input is going to go where x normally typically is. And then because x over 4 isn't just x, I have to do chain rule on that, and the derivative of x over 4 is 1/4. So you guys can see here that this expression then matches this, which is mathematically equivalent to what we began with. So arctangent of x over 4, that is our antiderivative. I'm going to take that, replace my integration part with arctangent of x over 4. Okay, and then now don't forget the 0 to b part, which good if you guys spotted that I didn't change this to b, which that should have been b on top. So let me do that real quick, 0 to b. And then we have our limit as b approaches infinity plus limit as b approaches negative infinity of arctangent of x over 4 from b to 0. Now plugging everything in, we have arctangent of b over 4 minus arctangent of 0, which in my mind I should know is 0. Arctangent of 0 minus arctangent of b over 4. And keep in mind that there's a limit that b approaches infinity for this portion of it, whereas this part of it, the limit is b approaches negative infinity. So let's evaluate our limit at this point. So limit as our arctangent approaches infinity over 4 is still infinity. So I want to picture that my arctangent function looks like this, where as it approaches infinity, it really approaches pi over 2, where pi over 2 is my horizontal asymptote, whereas negative pi over 2 is my horizontal asymptote when it goes to negative infinity. So pi over 2 here, this is 0, arctangent of 0, 0, and we can see that it passes through the origin. And then we've got 0 again here, so 0, 0, and then finally the limit as b approaches negative infinity over 4, which is just negative infinity, is negative pi over 2, and we have this minus sign here, so minus negative pi over 2, which gives us pi over 2 plus pi over 2, and magic, just pi.